How we make things in the world is changing. Some people are worried. We're not. We see it as an opportunity to become fully digital, climate neutral, and highly innovative in these challenging times. And EIT Manufacturing is leading the way. We're creating a Europe-wide community of businesses, students, researchers, engineers, workers, digital nomads who are all working to improve your everyday life.
Hello, my name is Aurea Rodriguez.
My name is Harry.
Nuno Gouveia.
Sebastian.
From France.
From Portugal.
We want to help
reduce energy waste
to transform and accelerate the European industry into the digital era. Bye.
Bye, guys. See ya. From a network of industry heavyweights to up-and-coming startups, we're constantly on the lookout for great partnerships. By pairing knowledge, talents, and the right skills, we're able to challenge what we already know and create the unexpected.
We want your ideas to come to life quicker, your investments to reach markets smoother, and to create more resilient supply chains.
It's worth fighting for. New friends, new skills, and smart machines fully connected using fewer resources and taking care of the planet. We're not just about education and innovation for the industry, but we're also about ideas that drive society forward and make it grow. A new Europe is emerging. It's green, connected, and digital. Are you ready? We are. Be part of the change.
The manufacturing sector has evolved over the decades, constantly adapting to fulfill the needs of economy and society. In its Industry and Innovation Lab, the iiLab INESC TEC aims to disclose the state-of-the-art in advanced production technologies, thus contributing to the industry's smart, sustainable and technology-based growth. Created in 2019 and headquartered in Porto, Portugal, the iiLab is a space for demonstration of research, experimentation, validation of new concepts and advanced training. The lab supports technology-based innovation in public and private organizations, thus enhancing their skills in the development, adoption and implementation of advanced production technologies. iiLab showcases a wide range of technologies such as mobile robotics, industrial vision systems, simulation, business intelligence and decision support systems, cyber-physical systems and Internet of Things. The lab provides a controlled, near-industrial test environment with production simulators, collaborative manipulators, cargo transport robots and IoT platforms. The technological demonstrators installed in the iiLab are transferred to different industrial sectors such as automotive, aeronautics, machinery, metalworking, textile, footwear and logistics. iiLab also provides professional training in digital transformation management and advanced production technologies for senior managers and engineers of manufacturing companies and technology providers. A specialized and experienced multidisciplinary team provides counseling to companies in order to support their digital transition and development of new and customized solutions. The laboratory works in close collaboration with other national and international initiatives, such as National European Digital Innovation Hubs and EIT Manufacturing, in order to spread digitization technologies across all industrial sectors in the region, thus accelerating the development of new industrial technologies and maximizing its impact, promoting the digital transformation and competitiveness of manufacturing companies.
we make things in the world is changing. Some people are worried. We're not. We see it as an opportunity to become fully digital, climate neutral, and highly innovative in these challenging times. And EIT Manufacturing is leading the way. We're creating a Europe-wide community of businesses, students, researchers, engineers, workers, digital nomads who are all working to improve your everyday life.
Hello, my name is Aurea Rodriguez.
My name is Harry.
Nuno Gouveia.
Sebastian.
From France.
From Portugal.
We want to help
reduce energy waste
to transform and accelerate the European industry into the digital era. Bye.
Bye, guys. See ya. From a network of industry heavyweights to up-and-coming startups, we're constantly on the lookout for great partnerships. By pairing knowledge, talents, and the right skills, we're able to challenge what we already know and create the unexpected. We want your ideas to come to life quicker, your investments to reach markets smoother, and to create more resilient supply chains.
It's worth fighting for. New friends, new skills, and smart machines fully connected using fewer resources and taking care of the planet.
We're not just about education and innovation for the industry, but we're also about ideas that drive society forward and make it grow.
A new Europe is emerging. It's green, connected, and digital. Are you ready? We are. Be part of the change.
The manufacturing sector has evolved over the decades, constantly adapting to fulfill the needs of economy and society. In its Industry and Innovation Lab, the iiLab INESC TEC aims to disclose the state-of-the-art in advanced production technologies, thus contributing to the industry's smart, sustainable and technology-based growth. Created in 2019 and headquartered in Porto, Portugal, the iiLab is a space for demonstration of research, experimentation, validation of new concepts and advanced training. The lab supports technology-based innovation in public and private organizations, thus enhancing their skills in the development, adoption and implementation of advanced production technologies. iiLab showcases a wide range of technologies such as mobile robotics, industrial vision systems, simulation, business intelligence and decision support systems, cyber-physical systems and Internet of Things. The lab provides a controlled, near-industrial test environment with production simulators, collaborative manipulators, cargo transport robots and IoT platforms. The technological demonstrators installed in the iiLab are transferred to different industrial sectors such as automotive, aeronautics, machinery, metalworking, textile, footwear and logistics. iiLab also provides professional training in digital transformation management and advanced production technologies for senior managers and engineers of manufacturing companies and technology providers. A specialized and experienced multidisciplinary team provides counseling to companies in order to support their digital transition and development of new and customized solutions. The laboratory works in close collaboration with other national and international initiatives, such as National European Digital Innovation Hubs and EIT Manufacturing, in order to spread digitization technologies across all industrial sectors in the region, thus accelerating the development of new industrial technologies and maximizing its impact, promoting the digital transformation and competitiveness of manufacturing companies.
make things in the world is changing. Some people are worried. We're not. We see it as an opportunity to become fully digital, climate neutral, and highly innovative in these challenging times. And EIT Manufacturing is leading the way. We're creating a Europe-wide community of businesses, students, researchers, engineers, workers, digital nomads who are all working to improve your everyday life.
Hello, my name is Aurea Rodriguez.
My name is Harry.
Nuno Gouveia.
Sebastian.
From France.
From Portugal.
We want to help
Reduce energy waste
to transform and accelerate the European industry into the digital era. Bye.
Bye, guys. See ya. From a network of industry heavyweights to up-and-coming startups, we're constantly on the lookout for great partnerships. By pairing knowledge, talent, and the right skills, we're able to challenge what we already know and create the unexpected.
We want your ideas to come to life quicker, your investments to reach markets smoother, and to create more resilient supply chains. It's worth fighting for. New friends, new skills, and smart machines fully connected using fewer resources and taking care of the planet. We're not just about education and innovation for the industry, but we're also about ideas that drive society forward and make it grow. A new Europe is emerging. It's green, connected, and digital. Are you ready? We are. Be part of the change.
The manufacturing sector has evolved over the decades, constantly adapting to fulfill the needs of economy and society. In its Industry and Innovation Lab, the iiLab INESC TEC aims to disclose the state-of-the-art in advanced production technologies, thus contributing to the industry's smart, sustainable and technology-based growth. Created in 2019 and headquartered in Porto, Portugal, the iiLab is a space for demonstration of research, experimentation, validation of new concepts and advanced training. The lab supports technology-based innovation in public and private organizations, thus enhancing their skills in the development, adoption and implementation of advanced production technologies. iiLab showcases a wide range of technologies such as mobile robotics, industrial vision systems, simulation, business intelligence and decision support systems, cyber-physical systems and Internet of Things. The lab provides a controlled, near-industrial test environment with production simulators, collaborative manipulators, cargo transport robots and IoT platforms. The technological demonstrators installed in the iiLab are transferred to different industrial sectors such as automotive, aeronautics, machinery, metalworking, textile, footwear and logistics. iiLab also provides professional training in digital transformation management and advanced production technologies for senior managers and engineers of manufacturing companies and technology providers. A specialized and experienced multidisciplinary team provides counseling to companies in order to support their digital transition and development of new and customized solutions. The laboratory works in close collaboration with other national and international initiatives, such as National European Digital Innovation Hubs and EIT Manufacturing, in order to spread digitization technologies across all industrial sectors in the region, thus accelerating the development of new industrial technologies and maximizing its impact, promoting the digital transformation and competitiveness of manufacturing companies.
make things in the world is changing. Some people are worried. We're not. We see it as an opportunity to become fully digital, climate neutral, and highly innovative in these challenging times. And EIT Manufacturing is leading the way. We're creating a Europe-wide community of businesses, students, researchers, engineers, workers, digital nomads who are all working to improve your everyday life.
Hello, my name is Aurea Rodriguez.
My name is Harry.
Nuno Gouveia.
Sebastian.
From France.
From Portugal.
We want to help
Reduce energy waste
to transform and accelerate the European industry into the digital era. Bye.
Bye, guys. See ya. From a network of industry heavyweights to up-and-coming startups, we're constantly on the lookout for great partnerships. By pairing knowledge, talent, and the right skills, we're able to challenge what we already know and create the unexpected.
We want your ideas to come to life quicker, your investments to reach markets smoother, and to create more resilient supply chains. It's worth fighting for. New friends, new skills, and smart machines fully connected using fewer resources and taking care of the planet. We're not just about education and innovation for the industry, but we're also about ideas that drive society forward and make it grow. A new Europe is emerging. It's green, connected, and digital. Are you ready? We are. Be part of the change.
The manufacturing sector has evolved over the decades, constantly adapting to fulfill the needs of economy and society. In its Industry and Innovation Lab, the iiLab INESC TEC aims to disclose the state-of-the-art in advanced production technologies, thus contributing to the industry's smart, sustainable and technology-based growth. Created in 2019 and headquartered in Porto, Portugal, the iiLab is a space for demonstration of research, experimentation, validation of new concepts and advanced training. The lab supports technology-based innovation in public and private organizations, thus enhancing their skills in the development, adoption and implementation of advanced production technologies. iiLab showcases a wide range of technologies such as mobile robotics, industrial vision systems, simulation, business intelligence and decision support systems, cyber-physical systems and Internet of Things. The lab provides a controlled, near-industrial test environment with production simulators, collaborative manipulators, cargo transport robots and IoT platforms. The technological demonstrators installed in the iiLab are transferred to different industrial sectors such as automotive, aeronautics, machinery, metalworking, textile, footwear and logistics. iiLab also provides professional training in digital transformation management and advanced production technologies for senior managers and engineers of manufacturing companies and technology providers. A specialized and experienced multidisciplinary team provides counseling to companies in order to support their digital transition and development of new and customized solutions. The laboratory works in close collaboration with other national and international initiatives, such as National European Digital Innovation Hubs and EIT Manufacturing, in order to spread digitization technologies across all industrial sectors in the region, thus accelerating the development of new industrial technologies and maximizing its impact, promoting the digital transformation and competitiveness of manufacturing companies.
Good afternoon. I would like to welcome everybody in the room and the 90 people participants in online. So welcome you all to our yearly event of EIT Manufacturing RIS Hub Portugal. This year we are here at INESC TEC Industry and Innovation Lab in Porto, Portugal. This event is organized by INESC TEC and its partners, INEGI and FEUP. Thank you, Margarida and Gil, for being with us. And also with the help with the EIT Manufacturing Co-location Center West. Thank you, Teresa Hernández and Javier González, that traveled all the way from San Sebastian to be with us here today. So we do have a 2 hours and a half full program for you. With presentations and demonstrations, and we would like to do this as much interactive as possible, so feel free to make your questions after each presentation or demonstration. For the people online, you have Graziella, that is your host there, and we'll be receiving your questions that will be posted here to the speakers in the room. And without further ado, I would like to introduce you to Luís Carneiro, member of the Board of Directors of INESC TEC, for a warm welcome. Thank you and enjoy.
Thank you, Anna. Good afternoon, everyone. Thank you for coming. Thank you for the ones here present. We almost didn't have enough chairs. Thank you to everyone that is attending online. Anna told already almost everything. Welcome here at this innovation Industry and Innovation Lab, the place that we built in the past few years to support companies in experimenting new technologies and supporting in their digital transformation, if you want. Here we have a lot of technologies, demonstrators that we've been developing along the years, and today we'll be demonstrating especially some technologies that we've been developing in scope of EIT Manufacturing. You saw already the video describing iiLab, describing also EIT Manufacturing. Just 2 words about EIT Manufacturing. For those less familiar, so it's a recent organization that aims to build I believe, the most important innovation community in manufacturing in Europe. So we believe very important to improve competitiveness, to improve employment across Europe. That's why we joined this initiative in partnership with FEUP and INEGI, as it was already described. Here with us we have also our networking partners, Produtec and Mobinov, which have been helping us in disseminating the event and all the work that we've been doing in these contexts, and which includes already, by the way, about 30 companies that we've been involving in the RIS Hub and in different projects that we've been developing here. EIT Manufacturing, as you know, has 3 main pillars. So very important, of course, to promote innovation and competitiveness. So we have the pillar about education, we have the pillar about innovation and business creation, and this triangle and its integration, of course, very important to manufacturing competitiveness. Today, we are going to see some examples of what we've been doing, especially under the innovation pillar and education pillar. So those would be the examples that I hope you like. The ones here present, I think it will be a bit easier. The ones remotely, I would like to invite to come here later on and see presently things that I believe are very relevant for the companies. So these were my words. Thank you very much for coming, and have a nice working session. So I think Javier is the next one. Thank you.
Yes, so Javier. Javier is the Education Director from Co-location Center West of EIT Manufacturing. And I take this opportunity to do already the presentation of the two speakers. So first, Javier will give you as an overall perspective of the education pillar in EIT Manufacturing. And then Ana Simões will give us the perspective of Portugal. So what have we till now contributed to the platform Javier is going to present. Thank you, Javier.
Thank you very much, Anna. Thank you very much, Luís, for the invitation and the introduction. So we are very happy to be here with you and with all the people connected online. So thanks a lot for coming to this event. My name is Javier González, education developer in CLC West from EIT Manufacturing, located in San Sebastian and in Spain. And we will today give you a few words about the activities that we do in the education pillar and in innovation pillar with my colleague Teresa, which will make a presentation afterwards. Now let's concentrate on the education part. So what we are doing in EIT Manufacturing in the education pillar. One of the key activities and the key actions that we are developing right now is the creation of an online learning platform, which we call Skills.move. Okay, today we will concentrate specifically on this activity, which has a lot of potential and has a lot of impact, and could have a lot of impact in the manufacturing industry in Europe. And I would like to give you some words about why are we doing this and what's the benefits and the potential that this platform can have for the manufacturing industry in the next coming years. So let's go quickly to the context and the approach that we follow with Skills.move. These figures that you see here, these are the representative of the European industry. You see the 20% of the total EU value added comes from the European from the industry. 80% of the exports in Europe are coming also from the industry. And 99% of European firms are SMEs and are part of the industry. So these figures are very, very relevant for us. But there is one figure that for us is also crucial, is that the European industry agglutinates 35 million workers in Europe. That is a huge number of people which needs training and could be trained in the future. And we need to do something for this, right? We from EIT Manufacturing, in our strategic objectives, we have it clear, and we want to reduce gaps in the skills and also to provide more skills for the workforce in Europe. We also want to empower women in the industry sector, which was traditionally thought as a men's sector. No, so we want also to create this, to foster that women are more empowered in the industry in Europe and create attractive workplaces. These are three of the main points that we want to follow in our work in education. Because we, at the very end, what we want is to transform the talent that we have in Europe in real impact. Impact in the market, impact in the society, more jobs, a greener society, and more economic development for Europe. This is the context in which we play right now within EIT Manufacturing. And our proposal to foster this skills upgrade, these needs of providing more training to the European industry, so these 35 million people working in the industry, is a Skills.move. So we have developed and we are developing an online platform in which we want also to provide content from the industry to the industry. And I will present you now briefly what is the aim of this platform and what we want to achieve with the implementation of Skills.move. This is the scene, as we have seen before, 35 million jobs, 2 million companies, and what is very, very interesting in all the reports, for example, from the World Economic Forum regarding the needs of upskilling and reskilling in the future years in Europe, it states that 40% of the workers will need some reskilling in the future. So we need to act for that, and we need to propose solutions, and we need to deliver good services, good products to overcome this situation. So for that, we from the EIT Manufacturing have, this is an overview about all our education programs, we propose some different initiatives in order to reduce these gaps and also to contribute for the education in the industry sector in Europe. We have 3 different programs: Empower, Connect and Transform and Engage, in which we deliver all the different services and actions to the manufacturing industry in Europe. But today we will concentrate specifically in the second one, Connect and Transform, where Skills.move is already included. It's for sure, it's very interesting to know that we also run master and PhD programs to educate students and to deliver all these initiatives for innovation and creation from this area in the universities. That's crucial. We also act with involving schools and young people and in the future talents in actions in the Engage program to foster the talent and foster also this initiative. But today we are focusing on the middle pillar, Connect and Transform, which is more focused on organizations, on the industry, right? And Skills.move is one of the tools that we will have for upskilling and reskilling the future talent in Europe. So that's what we want to get with Skills.move, to empower individuals. So we are focusing on people, we are focusing on the learners, to empower individuals with the right skills for the future. How we do this? Skills.move, as I mentioned, is an online platform that helps the manufacturing industry to upskill and reskill the workforce. And also with the experience that we get from our projects, the activities that we develop in EIT Manufacturing, with the contribution of all of our partners and all of the ecosystem surround of our partners, and also avoiding big investments in these platforms. So saving, also trying to provide service which can make the companies to save money. That's one of the aims of the platform. It's in line with the needs of the industry. It's created by the industry, which is mentioned here, so 100% manufacturing industry focus. Engaging the different hands-on methodologies and educational methodologies like teaching and learning factories as a new and revolutionary way of education, to provide education in the industry, and also focused on skills and competencies through a customized learning paths and learning journey which can be created by the users. I will show that afterwards. This is focused to workers, managers, teachers, so we are covering a lot of stakeholders which can make use of that, because remember that we are focusing on the people, so on individuals, right? And individuals will be the workers of the future, and this is a tool for educating them. The architecture of the platform, as you see here, is learner-centric, so we're focusing on that with a strong quality and content quality check to provide good quality content with hands-on experience, as I have mentioned before, about the teaching and learning factories activities that will be embedded in the platform, with the possibility of certifying the training that we do, which is very, very relevant now, so to get a certification of the trainings, with different options for subscription, with learning management, reporting capabilities, and the possibility of including new content in the platform. The platform will be constantly updated with content which is relevant and interesting for the industry. The concept behind Skills.move is, as I mentioned before, just with all the learning units that are created initially from the projects that we have funded in EIT Manufacturing, so including all this content in the platform, which can allow us to create our tailored learning paths depending on the sector, on the company, or on the need of the trainees that we need. It is possible to combine these different learning units in customized learning paths, which combined as well can create learning journeys which can provide added value for the jobs of the future. So the learning units are free of charge. We can consume these learning units by free of charge in the platform, and the learning paths and learning journeys are by payment, because we can provide certification for that. This is how the the concept of a Skills.move is created. So it can be adapted to any industry, to any need, and also to be updated with the latest content and the latest activities and the latest development in the technologies related to the manufacturing sector. As you can see here, so the content is created in different ways of formats, in format and video. We can also have animations, we can have different schemes and quizzes, slides that can be also used and, as I mentioned, combined to create your customized learning journeys and learning paths. And the platform is now in a beta phase testing, so we are testing that everything is working correctly so that we can launch this by the end of the year, and at the beginning of 2022. So we invite you to stay tuned because the platform will be soon available for all of you so that you can start using that, start testing the content, consuming the content, learning, which is what we want with this learning platform, which will be very, very interesting for the next coming months. So thank you very much for your attention. Thank you very much to INESC TEC for hosting us here. So I'm fully available for you. This is my contact if you want to have any question for us, and any question from here is also possible. So thank you very much for your attention. Thank you.
Thank you, Javier. So questions from the audience? It looks we don't have questions online, but we can still have those coming. And I ask the audience presence here, questions for Javier? They are also excited to use the platform.
Yeah, wait. We are looking forward to receiving your...
just waiting for using it.
That's great, that's great. No, we will see very good examples right now. That's fine.
So if no questions at the moment, Anna Simões will continue.
Thank you very much.
Thank you. Hi, everyone. Good afternoon. I'm going to present I'm going to do the presentation entitled Boosting Digital Education, the Portuguese Contributions to Skills.move. This presentation received inputs from our partners in Portugal, INESC as well as INESC TEC, and I'm a researcher at INESC TEC. So, for this presentation, I structured it in 4 main points. At first point, I will talk about education and risk projects that contribute to Skills.move, the platform that Javier introduced before. Then I will talk a little bit on professional schools that are made online based on Skills.move platform, the pilots that are running this year. Then I will speak a little bit about the industrial doctorate program that also Javier mentioned in the previous presentation. And finally, how we see the future of contributions between the Portuguese partners and Skills.move. Okay? Let's move to our first point. I present in this slide the perspective of the contributions projects that contribute to Skills.move. So, as you can see, in the last year, 2020, we have 5 projects contributing to Skills.move in the education pillar as well as in education risk pillar. This year, 2021, we have 11 projects, more than double than the last year, with contributions, education projects that as part of contributions with the learning, digital learning contents to the Skills.move. And we have 10 projects pre-selected on the business plan of EIT Manufacturing in the education pillar for 2022. Let's move on. In this table, I present the contribution of each of the projects running during the last year, 2020, during the previous year, 2020, the number of nuggets that were produced in this project, as well as the Portuguese contribution for these nuggets. You are asking what are nuggets, okay? Nuggets are the digital content that is created in the project that are implemented in Skills.move. So a learning path is a sequence of nuggets, the digital contents, okay? So what we have for the MNEST 1 project, we developed in the project 98 nuggets, 14 of each were developed inside the Portuguese partners, FEUP, INESC, and INESC. In MNEST RIS, that is a RIS education project, we developed 65 nuggets, 19 of each were developed by the Portuguese consortium. The CPPS developed 60 nuggets, 30 of each were developed by FEUP and INESC TEC. I put a note on these nuggets because some of the nuggets are not exclusively developed by Portuguese organizations, but also in collaboration with other European partners. The MirrorLabs developed 27 nuggets, 8 of each by INESC TEC, and finally Shaping developed 5 nuggets, all of them developed by FEUP and INESC. Move to the professional schools. I will do like a summary of what have been done during this year in the pilots of these 3 projects. In MNEST project, we developed 17 learning pads based on the nuggets produced on the last year on MNEST 1 and MNEST RIS projects. Based on these learning pads, we contact the companies in each country of the partners that belongs to this consortium and try to survey them in terms of training needs. Okay? Based on the responses of this survey, we are adapting these learning generic pads by customize them to the specific needs of the companies. These pilots, specific designs for these companies, will be run during the next month, November, and since we are pilot them, they are for free. In DigiMan, the approach is a little bit different. In this project, 5 models, learning models were developed. These models will be running in 2 semesters. The first one will start this month till December, and the second semester on the next year. So if the ones that want to register on these models related to cyber-physical system, data analytics, human-robot interaction, entrepreneurship, and innovation must do it by the end of this week. And these courses has a fee of 500 euros. Finally, MirrorLabs also have been developing nuggets for the Skills.move. The approach is a little bit different. So they used learning pads developed last year in MirrorLabs 1 on automated guide vehicles, extended reality basics, immersive experiment, extended reality and cobots, and collaborative robots for SMEs. And this year, this consortium is updating these learning pads, trying to redirect them and add some nuggets in order to serve the company's needs in terms of training. Okay? These nuggets or these learning pads can be consumed in Skills.move, but for certificate we have to pay a cost to have the certificate on these topics. For EIT Manufacturing Doctoral School, it's a concept that was created by EIT Manufacturing with the partners, university partners. We have here the 6 universities that belong to this project. Portuguese is represented here by Faculty of Engineering of University of Porto. These programs, these PhD programs, are very related to the companies, to the industrial companies, since the industrial companies have the opportunity to expose a real challenge, a real problem of their sector, of their company in particular. The companies that are interested in presenting this challenge have to contact one of these universities, present the challenge. The challenge will be evaluated for their scope or their alignment with the EIT Manufacturing Doctoral School. Since it is approved by that committee, that topic would be available for students to choose for their PhD works. Finally, I will talk a little bit about how our Portuguese organizations envisage the collaboration with EIT Manufacturing in general and Skills.move in particular. We call them the blended courses. Why blended? Because we see this contribution as a value creation from both parts, the partners from Portugal and other countries for sure, and Skills.move. So if INESC TEC, for example, wants to run a training program specific for a company, we can get some digital contents from the Skills.move, as well as create our INESC TEC own contents, digital contents, and deliver them to the trainees. This is the first part, and they can run, for example, at the trainee home or at the company. The second stage of these blending courses will be run at the physical infrastructure, for example, in infrastructures like iiLab, and can have a component of hands-on experience, an experimental component of the learning, with the possibility of using the physical structure, the equipment, the platforms that are physically installed in a place like iiLab. So, it's all. I hope everyone understands how the Portuguese partners have been contributing to Skills.move. Any questions, please? Thank you.
Thank you, Ana. Questions for Ana?
No questions?
I hope you get more excited during coffee break, so you awake for the questions. And I think I have to go there so people can see me. I just coming here to say hello again to the people online and to welcome Teresa Hernández. Thank you so much for being here. So Teresa is the Innovation Director of the EIT Manufacturing Co-location Center West and will tell us a lot of Tech Radar today. Thank you, Teresa.
Thank you very much. So, welcome everyone, and thank you for being here. It's very, very nice to see all your beautiful faces in front of me. I've really got annoyed by the screen scene, you know, and it's really good to have you here. This is the first speech for me after the pandemic, and I'm really excited about that. And, you know, if I would have done this speech before the pandemics, I would have started to say, okay, we are living in an accelerating world, everything is changing so quick, but then the pandemic came and everything stopped. Or not. No, it really didn't stop at all. It accelerated change, indeed. You know that the use of digital tools increased around 700% during the pandemic. Most of us have been at home working with our computers. We have learned to use Zoom. We have learned to use Teams. We have learned to use a lot of new technologies that we didn't use before. And you know, this is also for manufacturing, but for manufacturing it's not that easy because you need to fabric physical goods, and it's not that easy to digitalize, but this is also happening. One of the biggest challenges that has manufacturing is this digitalization that we have suffered during the pandemic. But also, we have suffered during the pandemic the scarcity of things. We didn't have masks. We didn't have ventilators. And this is another of the challenges we are seeing that manufacturing in Europe needs to tackle. Because we need to make a manufacturing that it's more flexible and can adapt to the customer needs. And also manufacturing, it's polluting. You know, it's polluting our rivers, our seas, our air. And we also need to make manufacturing more sustainable. And this is another of the challenges we have. And we have these three biggest challenges, and the tools to address these challenges are technologies. And that's the reason we have created the radar. The radar is a comprehensive tool, an instrument to show the technologies that are paving the way to the future of manufacturing. So what we have done is that we have gathered 40 technologies so far, and we have put them together into different trends, into 4 different trends. And what's the reason for this radar to exist? To inspire you, to inspire all our community to create the solutions to address the main challenges of manufacturing. I'm going to talk you a little bit about the trends we have discovered, so I hope this will inspire you to create new projects. So the first one is hyperflexibility, and it's very connected with this first idea of the mask scarcity during the pandemics. But it's also connected with the needs of customers and the personalization our customers are demanding. So hyperflexibility, it's about making our manufacturing as much flexible as possible. And within this trend, we can find technologies like the industrial 3D printing. You all know about that. I have seen them working, and it's amazing how you can now print very different structures that you couldn't print before, or how you can remanufacture a part of an engine that has been broken without creating a new one. So industrial 3D printing is one of these technologies with a high TRL that it's helping us to be more flexible, and it's enabling industries to create these complex parts that before couldn't be created. But also in the radar, you can find technologies like this, which is the programmable liquid material, or metal, sorry. And you know, I remember that I went to an exhibition in the Reina Sofia Museum in Madrid a long time ago, around 6 or 7 years ago. And there was an artist that was playing with this type of material. And it's like a liquid metal, and then you use magnets, and you can produce different shapes. And you could think, well, but what's the application but ours for these type of technologies? And but we can start to think about chips that can reconfigure themselves thanks to these liquids, or that can change and program themselves differently in order to do different tasks. So this TRL, the TRL of this technology is quite low right now, but I mean, this is something that it's coming, and we need to find some applications for that. The second trend that we have in the radar is the human and machine collaboration. And this is very important because in the past, everything has been about automatization, and we need to rethink this and to put the machines at the service of the operator and make the machines so nice, attractive, and intelligent that can help the person, the human, to do their work better. And here, of course, you can find exoskeleton as a technology. We all have seen Robocop, so we all know what is a skeleton, exoskeleton. But you can find this technology as well, which is artificial superintelligence, which is not the artificial intelligence we have today, which is not very intelligent yet. This is about when the computers are going to surpass our human capabilities. And this is also something that will happen in the future for sure, because there's a lot of money and a lot of brains put into that. And we need to figure out the ways how this artificial superintelligence is not going to replace us, but make us much better workers. And the third trend we have is the factory floor orchestration. So what's happening there is that in a factory you have different elements, different machines, people working, and you need systems that put all the elements together and help them to work like in a symphonic orchestra. So you can find this robot communication interface as one of the technologies in the radar. And I'm very glad that we are supporting right now in our community Synsoft Industry. They are the winners of our first Boost Up competition. And what they have is they have the Alexa of the industry, the Siri of the industry. So workers will be able to communicate with a voice or a system, and will allow them to perform tasks just by using their voice, like capturing data or asking for the pressure of a certain machine or things like that. And this is an example of a technology that it's already commercialized. But we also have the edge computing. And edge computing is something that is happening now, and with the coming of 5G and the intersection of this type of computers, we will be able to perform tasks right now in the line that cannot be performed. Today I was talking with the activity leaders of one of our projects, Pick a Future, and we were talking about they have this system that picks a fish, recognizes the fish, and selects which is the right bin to put it in. And it was very nice because he was saying me, okay, we are testing this, but our operators do these tasks and perform these tasks faster than the robot. Of course, it's a prototype, it's a pilot, but with the coming of the edge computer and 5G, this can change. And the robot will be faster than the operator. So this is one of the potentials of edge computing. And the last of the trends is the location-independent factory. And this means that you can be everywhere, and then it can be, the things can be manufactured independently of the location. And some examples of technologies we have is, one is digital twin, and we're working with a startup which is Infinite Foundry, that they create 3D plants, 3D digital plants in a very easy way. So they can scan the plant and create a model in the virtual that represents the fabric. And the digital twin is something very attractive because it allows you to test things without doing it in the proper machine, or understand the behavior of a certain machine, or do predictive maintenance in order to make sure you don't need to stop the work of a factory. But you also have among these technologies the metaverse. I don't know if you have heard about the metaverse, but the metaverse is it's becoming a wide discussion right now in Silicon Valley, because there are one of those big gurus speaking about they want to create the next metaverse. But the metaverse is a virtual world where we can step in. And it's going to be very good for learning for acquiring new learning skills. And we will have avatars, and we will be able to go there and learn what's a factory, how it can behave, how do we need to behave within that factory. So they are perfect learning environments, but also we will need to figure out what the things that are going to be consumed in the metaverse will be manufactured. So it's another type of manufacturing. The radar. What's the vision for the radar? The radar needs to become the place where everyone that wants to learn anything about technologies of manufacturing goes. I foresee it as a tool for all of you to get inspiration to solve the main challenges of manufacturing. So thank you very much. You have a QR code so you can scan and look at the radar in your mobiles. And please explore it and share it. Thank you.
Thank you so much, Teresa. Questions? There is one question from the online participants.
Actually, the question is for Anna. I'm sorry.
No problem, no
it's
problem.
It's a bit delayed.
Come, Anna. Come here. So they can see you.
The question from Geert Postma is, if I'm correct, several of the presented courses are set up in the context of EU projects. So is the content of these courses also available for other didactic factors in Europe?
The contents that we develop in the projects, EIT projects in this case, are based on our research in our research centers or in the universities. So the knowledge that you use to develop that digital contents or other type of contents for sure are transversal to other projects. And yes, you can use some synergies between the projects, European as well as national or funded by IoT Manufacturing to improve the knowledge, to improve the skills of the operators, of the people in the companies. Thank you.
More questions here? Desculpa.
Thank you for your presentation, Teresa. So, regarding updating the radar, how will you do it? So annually, because as a radar, it needs to be kept alive, right?
Yes. We plan to update it right now yearly, but if we see a lot of use of it and we scale and broaden the people that gets to it, probably we will consider to update it more frequently. Right now we have considered to update it once a year.
Okay.
And it's relevant for us because we want to link it as well with the organizations working in the technologies. So in the radar you will see that you have the technology, the description of the technology, some more contents you can link on, some links that can bring you more information about that, but also organizations that are working with those technologies. And we want it to become a place where also you can find not only the inspiration, but also the connection to the people that it's already working with the technologies.
Okay, well done. Thank you.
Thank you, Anna.
So we will now continue. Thank you, Teresa, and Anna, and Javier. So we come now to the second part of our event, which is demonstrations. And this is the two parts. So first we have 5 demonstrations of EIT manufacturing projects that we have been involved in the past 2 years that we will demonstrate here. And the second part is demonstrations of 2 European projects, where we will show in the first one how to use the results of Age Europe projects as an input to EIT manufacturing activities. And the second one, how do the technologies that you see here all in this Industry and Innovation Hub end up in the real world, in the industry, in the factories. So this is our proposal for now. This is how it's going to work. We have the first demonstration is still a presentation. So we will have this setting with João presenting. And then we will have the coffee break we have in the room. And after that, we will have free room for the robots to travel and for us to see all the demonstrations here in the room. So for now, I will pass the word to João Basto, who is going to show us some results of EIT Manufacturing this year. Thank you, João.
Thank you, Ana. So I'm João. I'm from INESC, as Ana said, and I'm going to present you a bit of a project that we are doing now called AM-HLP, and where we are trying to solve inventory management in manufacturing supplier networks. So in this brief presentation, I will start by giving you a context of the problem that we were trying to solve, how we solved it, some future opportunities that are open. Basically, AM-HLP is a nickname for Additive Manufacturing for Hospitals learning program. And the main objective is we want to empower hospitals to use this additive manufacturing technology that now is one of the trending topics, even Teresa presented it a bit. And we want to make sure that hospitals are aware of how to use it to deal with situations such as the pandemic, with a sudden increase of demand of consumable parts. And in this project, it's us, INESC TEC. We also have Fraunhofer, INEGI, and Polytechnic Milano. So the project in our side builds upon something we did, which is the 3D log project. We cover all the skills related to inventory management in these cases. And that's what I will try to give you, is a little overview of what kind of skills we need and that we are developing in the project to deal with the situation of inventory management in this scenario. So, giving you a brief presentation of how it all started, we were in the beginning of 2020. Maybe you weren't aware there was a pandemic, and it was a crazy situation for the hospitals, with a sudden increase of masks, nasal swabs, and face shields that was needed, and that there was no way to be produced in a short time. And what we did here in the north of Portugal, several volunteers created this network. They all had 3D printers, they wanted to help, and so they started making face shields to deliver to the hospitals. Now, the initiative is great, but it has a very big challenge in terms of logistics, because clearly you don't have production enough for everyone. You need to have some kind of logistic background to decide on how you will share all the things that you are making through all the hospitals. And this is extremely difficult to manage when you are in a volunteer, so it is not your work. You don't have 8 hours a day to focus on this. And what the first solution they came up with before the project was, well, let's share the Excel file on a drive. Everybody puts there their information, how many pieces they have to produce in the facilities of their factories. The hospitals can put also their information and what is the demand that they require for each day. And then there was this one person who would manually do allocations. Like, this producer will give his parts to hospital A, this one to hospital B. And yet, not only to do these allocations, but also to define a route. So he would have to say how a person would take all the parts from the different people that were volunteering to produce parts to deliver to the hospital. So as you can see, there is a problem of there is no data protection in this solution. Everybody could see the addresses and the phone numbers of everyone, which is a complete violation of the regulations we have nowadays. And furthermore, we could see that there was a high degree of potential for automation. So when we have one person making this kind of decisions, not only we could save time of this person, because these decisions could be automatic. Furthermore, the decisions could be made in an optimized form. Maybe the route that he is selecting is not the best route. Maybe there was a way to do it that would be faster, lead to less costs, and cover a less distance, so also more environmental. And then we came up with this solution. So this is a web-based application, which means that there is a user registration and authentication. Now, not everybody can enter there and just see the data. We have some control over it. Plus, we have role-based permissions. So not everyone can do everything. The supply manager has its role and is able to have a clear view of the supply network. You can see what's going on, what are the demand requests, what are the production orders currently working on. But there is also the data protection part where, given that everyone has a role, we now have a clear definition of what everyone can see. And as you can see, this is much better than the previous solution. Now we have a complete tracking of what's going on. We can gather historical data that we can collect to face current waves of the pandemic, for example. And we enabled the platform with artificial intelligence. So to that part of deciding where, which is the route that should be followed by the logistic partners, which producers should provide to which hospital, we have an algorithm, an AI algorithm that does these decisions much faster and with much more optimization than the supply manager would do. So what is the future of this approach? Well, there's the obvious one that I mentioned in the beginning. We are taking the skills, taking the know-how that we accumulated with the project, and we are using it in AM-HLP to provide to the hospitals. The other obvious conclusion that we can get is that this is very extensible to other contexts. We don't need it to be additive manufacturing products. For me, it's not different if the volunteers are producing a 3D printed part or if they are making nasal swabs or masks. In fact, in the late stage of the project, we extended it for masks and nasal swabs to provide to the hospitals. And furthermore, the possibility to create more new added value modules. So we can have a demand forecast. If we are collecting all the data of all the demand, all the production, we can predict what will happen in the supply network in the future. And furthermore, we can do stock management properly. So why do we have hospitals telling us what they need? If they are telling us what is the stock level, maybe we could do this management in an optimized form and ease the effort of the volunteers and of the people that are making the 3D printed parts. So that was it. Thank you. Any questions, please feel free to contact me, and thank you. Thank you.
So thank you, João. And as promised, we have coffee break now. And for the participants online, you will have some very nice videos to get to see the next minutes. So we will have a 15-minute break, and we will come afterwards with the demonstrations. Thank you.
The manufacturing sector has evolved over the decades, constantly adapting to fulfill the needs of economy and society. In its Industry and Innovation Lab, the iiLab INESC TEC aims to disclose the state-of-the-art in advanced production technologies, thus contributing to the industry's smart, sustainable and technology-based growth. Created in 2019 and headquartered in Porto, Portugal, the iiLab is a space for demonstration of research, experimentation, validation of new concepts, and advanced training. The lab supports technology-based innovation in public and private organizations, thus enhancing their skills in the development, adoption, and implementation of advanced production technologies. iiLab showcases a wide range of technologies such as mobile robotics, industrial vision systems, simulation, business intelligence and decision support systems, cyber-physical systems and Internet of Things. The lab provides a controlled, near-industrial test environment with production simulators, collaborative manipulators, cargo transport robots and IoT platforms. The technological demonstrators installed in the iiLab are transferred to different industrial sectors such as automotive, aeronautics, machinery, metalworking, textile, footwear and logistics. iiLab also provides professional training in digital transformation management and advanced production technologies for senior managers and engineers of manufacturing companies and technology providers. A specialized and experienced multidisciplinary team provides counseling to companies in order to support their digital transition and development of new and customized solutions. The laboratory works in close collaboration with other national and international initiatives, such as National European Digital Innovation Hubs and EIT Manufacturing, in order to spread digitization technologies across all industrial sectors in the region, thus accelerating the development of new industrial technologies and maximizing its impact, promoting the digital transformation and competitiveness of manufacturing companies.
How we make things in the world is changing. Some people are worried. We're not. We see it as an opportunity to become fully digital, climate neutral, and highly innovative in these challenging times. And EIT Manufacturing is leading the way. We're creating a Europe-wide community of businesses, students, researchers, engineers, workers, digital nomads who are all working to improve your everyday life.
Hello, my name is Aurea Rodriguez.
My name is Harry.
Nuno Gouveia.
Sebastian.
From France.
From Portugal.
We want to help
reduce energy waste
to transform and accelerate the European industry into the digital era. Bye.
Bye, guys. See ya. From a network of industry heavyweights to up-and-coming startups, we're constantly on the lookout for great partnerships. By pairing knowledge, talent, and the right skills, we're able to challenge what we already know and create the unexpected.
We want your ideas to come to life quicker, your investments to reach markets smoother, and to create more resilient supply chains. It's worth fighting for. New friends, new skills, and smart machines fully connected using fewer resources and taking care of the planet.
We're not just about education and innovation for the industry, but we're also about ideas that drive society forward and make it grow.
A new Europe is emerging. It's green, connected, and digital. Are you ready? We are. Be part of the change.
The manufacturing sector has evolved over the decades, constantly adapting to fulfill the needs of economy and society. In its Industry and Innovation Lab, the iiLab INESC TEC aims to disclose the state-of-the-art in advanced production technologies, thus contributing to the industry's smart, sustainable and technology-based growth. Created in 2019 and headquartered in Porto, Portugal, the iiLab is a space for demonstration of research, experimentation, validation of new concepts and advanced training. The lab supports technology-based innovation in public and private organizations, thus enhancing their skills in the development, adoption and implementation of advanced production technologies. iiLab showcases a wide range of technologies such as mobile robotics, industrial vision systems, simulation, business intelligence and decision support systems, cyber-physical systems and Internet of Things. The lab provides a controlled, near-industrial test environment with production simulators, collaborative manipulators, cargo transport robots and IoT platforms. The technological demonstrators installed in the iiLab are transferred to different industrial sectors such as automotive, aeronautics, machinery, metalworking, textile, footwear and logistics. iiLab also provides professional training in digital transformation management and advanced production technologies for senior managers and engineers of manufacturing companies and technology providers. A specialized and experienced multidisciplinary team provides counseling to companies in order to support their digital transition and development of new and customized solutions. The laboratory works in close collaboration with other national and international initiatives, such as National European Digital Innovation Hubs and EIT Manufacturing, in order to spread digitization technologies across all industrial sectors in the region, thus accelerating the development of new industrial technologies and maximizing its impact, promoting the digital transformation and competitiveness of manufacturing companies.
How we make things in the world is changing. Some people are worried. We're not. We see it as an opportunity to to become fully digital, climate neutral, and highly innovative in these challenging times. And EIT Manufacturing is leading the way. We're creating a Europe-wide community of businesses, students, researchers, engineers, workers, digital nomads who are all working to improve your everyday life.
Hello, my name is Aurea Rodriguez.
My name is Harry. Nuno Gouveia.
Sebastian. From France.
From Portugal.
We want to help
reduce energy waste to transform and accelerate the European industry into the digital era. Bye.
Bye, guys. See ya. From a network of industry heavyweights to up-and-coming startups, we're constantly on the lookout for great partnerships. By pairing knowledge, talents, and the right skills, we're able to challenge what we already know and create the unexpected.
We want your ideas to come to life quicker, your investments to reach markets smoother, and to create more resilient supply chains. It's worth fighting for. New friends, new skills, and smart machines fully connected using fewer resources and taking care of the planet. We're not just about education and innovation for the industry, but we're also about ideas that drive society forward and make it grow. A new Europe is emerging. It's green, connected, and digital. Are you ready? We are. Be part of the change.
The manufacturing sector has evolved over the decades, constantly adapting to fulfill the needs of economy and society. In its Industry and Innovation Lab, the iiLab INESC TEC aims to disclose the state-of-the-art in advanced production technologies, thus contributing to the industry's smart, sustainable and technology-based growth. Created in 2019 and headquartered in Porto, Portugal, the iiLab is a space for demonstration of research, experimentation, validation of new concepts and advanced training. The lab supports technology-based innovation in public and private organizations, thus enhancing their skills in the development, adoption and implementation of advanced production technologies. iiLab showcases a wide range of technologies such as mobile robotics, industrial vision systems, simulation, business intelligence and decision support systems, cyber-physical systems and Internet of Things. The lab provides a controlled, near-industrial test environment with production simulators, collaborative manipulators, cargo transport robots and IoT platforms. The technological demonstrators installed in the iiLab are transferred to different industrial sectors such as automotive, aeronautics, machinery, metalworking, textile, footwear and logistics. iiLab also provides professional training in digital transformation management and advanced production technologies for senior managers and engineers of manufacturing companies and technology providers. A specialized and experienced multidisciplinary team provides counseling to companies in order to support their digital transition and development of new and customized solutions. The laboratory works in close collaboration with other national and international initiatives, such as National European Digital Innovation Hubs and EIT Manufacturing, in order to spread digitization technologies across all industrial sectors in the region, thus accelerating the development of new industrial technologies and maximizing its impact, promoting the digital transformation and competitiveness of manufacturing companies.
How we make things in the world is changing. Some people are worried. We're not. We see it as an opportunity to become fully digital, climate neutral, and highly innovative in these challenging times. And EIT Manufacturing is leading the way. We're creating a Europe-wide community of businesses, students, researchers, engineers, workers, digital nomads who are all working to improve your everyday life.
Hello, my name is Oriana Rodriguez.
My name is Harry. Nuno Gouveia.
Sebastian.
From France.
From Portugal.
We want to help
reduce energy waste
to transform and accelerate the European industry into the digital era. Bye.
Bye, guys. See ya. From a network of industry heavyweights to up-and-coming startups, we're constantly on the lookout for great partnerships. By pairing knowledge, talent, and the right skills, we're able to challenge what we already know and create the unexpected.
We want your ideas to come to life quicker, your investments to reach markets smoother, and to create more resilient supply chains. It's worth fighting for. New friends, new skills, and smart machines fully connected using fewer resources and taking care of the planet. We're not just about education and innovation for the industry, but we're also about ideas that drive society forward and make it grow. A new Europe is emerging. It's green, connected, and digital. Are you ready? We are. Be part of the change.
The manufacturing sector has evolved over the decades, constantly adapting to fulfill the needs of economy and society. In its Industry and Innovation Lab, the iiLab INESC TEC aims to disclose the state-of-the-art in advanced production technologies, thus contributing to the industry's smart, sustainable and technology-based growth. Created in 2019 and headquartered in Porto, Portugal, the iiLab is a space for demonstration of research, experimentation, validation of new concepts and advanced training. The lab supports technology-based innovation in public and private organizations, thus enhancing their skills in the development, adoption and implementation of advanced production technologies. iiLab showcases a wide range of technologies such as mobile robotics, industrial vision systems, simulation, business intelligence and decision support systems, cyber-physical systems and Internet of Things. The lab provides a controlled, near-industrial test environment with production simulators, collaborative manipulators, cargo transport robots and IoT platforms. The technological demonstrators installed in the iiLab are transferred to different industrial sectors such as automotive, aeronautics, machinery, metalworking, textile, footwear and logistics. iiLab also provides professional training in digital transformation management and advanced production technologies for senior managers and engineers of manufacturing companies and technology providers. A specialized and experienced multidisciplinary team provides counseling to companies in order to support their digital transition and development of new and customized solutions. The laboratory works in close collaboration with other national and international initiatives, such as National European Digital Innovation Hubs and EIT Manufacturing, in order to spread digitization technologies across all industrial sectors in the region, thus accelerating the development of new industrial technologies and maximizing its impact, promoting the digital transformation and competitiveness of manufacturing companies.
Welcome to our second part of the EIT Manufacturing RISHub Portugal event. This time, this year, here at INESC TEC Industry and Innovation Lab in Porto, Portugal, in collaboration with the INESG and FILP and also with the EIT Manufacturing Co-Location Center West. And this part is all about demonstrations. So we have 5 demonstrations from EIT Manufacturing projects, and then we'll have 2 demonstrations of H2020 projects. The first one will show how you use H2020 results for the EIT manufacturing activities, and the second one will show us how to bring all these technologies that we see here in the lab and how they are being used at the industry. So without further ado, I pass the word to Marcelo for the first demonstration. Thank you, Marcelo.
Hi, thank you, Anna. Thank you all for coming here, both virtually or in presence. I'm Marcelo, and this is Gustavo, and we are going to show you the AR-based human-robot interaction. The AR-based human-robot interaction is a demonstrator implemented under the MirrorLabs project. And the MirrorLabs project consortium is composed by INESC TEC, TU Delft, Aalto University, TU Braunschweig, SUPSI, and LMS. Well, manufacturing companies are increasingly adopting smarter and more connected technologies, but the human operator is still playing a very important role in the shop floor. Actually, the cooperation between the human operator and the machines is able to outperform the performance of each one working individually. But delivering this kind of collaborative and flexible environment is very hard to achieve, and increases the level of hardness. For that, it's very important to improve to enhance the human-robot interface, and also to deliver the proper amount of information to the operator. In this demonstrator, we are going to show you a human-robot interface system based on augmented reality. And through this system, the operator is able to visualize relevant information of the status of the robot and of the production environment. He's able to program the robot using by hand guiding the digital twin of the real robot, and also monitor the workspace. So I think we are all here for the demonstration. I will ask Gustavo now to start the demonstration. Gustavo is going to he's going to connect with a database in which we have several programs already in place, and he's going to start the robot. So you can see here, he interacted with the real robot to this virtual interface. Gustavo is wearing a HoloLens 2 augmented reality device. So through this device, Gustavo is able to see the shop floor, and at the same time, we are able to project digital content on overlaid on the real environment. So he can see the robot, but he can also see other information. Here you can see in the screen the same view that Gustavo has. So we have the digital twin of the robot, and in orange we have another robot that Gustavo will be using for programming the robot. So here you can see Gustavo was also able to check information about the status of the robot. In this example, he can see the position and the velocity of each one of the robot joints, but he could also easily see information about the part that is being produced or other relevant information that could be displayed. Gustavo is now going to program the robot using the digital twin. So it's very easy. Gustavo will manipulate the virtual robot, and he's going to save the pose of the desired path that he wants. And To check if the position is right or not, we are going to overlay a reference frame on the environment, so Gustavo can constantly check if this position is right or not, and he could rewrite the program. So he can save as many waypoints as he wants. These waypoints contain not only the position of the end effector, but also the orientation of the end effector. And then Gustavo is able to save the program and play the program he just created. So you can see here the digital twin of the robot, but you can also check that the real robot is reproducing the same behavior. Oops. Okay. Another interesting feature that we are developing is the safety. So we consider that safety is very important for the operator 4.0. So the HoloLens, or the AR device, is also able to monitor the robot workspace. So for that, we created a 3D volume around the robot that Gustavo is able to see. So he can avoid this working space to avoid the robot colliding with him. But at the same time, with the sensors that we have on the AR device, we are able to track Gustavo's hands and head. So we know where Gustavo is at each time, and every time that Gustavo infringes the safety zone, the HoloLens sends to the robot a signal to reduce its speed, or even come to a complete stop and avoid dangerous situation. So when Gustavo approaches the robot reduces its speeds to around 10%, and when he comes back outside the safety zone, the robot goes back to its original speed of 100%. So this device, it can work with one robot, but it could also work with the entire factory. So the HoloLens can be connected to multiple robots, to multiple production cells, and it can work as an individual protection equipment. So Gustavo is safe. Of course, Gustavo is safe while using and while the device is able to communicate with the robot or with the production cell. So if you have any questions, I'm happy to address them for you. Otherwise, we can chat in the end of the session. Thank you very much.
Thank you, Marcelo and Gustavo, for the demonstration. Thank you so much. So we will now pass to the next demonstration, and it's a very particular project for us. It's our first cross-kick project. So EIT has actually 8 kicks. So, and this one, they collaborate with, among each other. And this project has the collaboration with EIT Digital, Food, and Manufacturing. And Rui Dias is going to tell us all about iFishCan. Thank you, Rui.
Okay, thank you. Thank you, Anne. Good afternoon, everyone. I'm Rui Dias, and I will present the iFishCan project, which is this demonstration. It's about the iFishCan project that will be implemented in the fish canning industry, more specifically in a company in Matosinhos, a sardine scanning company, and in another in the Bilbao region in Spain, a company of tuna fish canning. This demonstration is part of a solution that which aim is reduce the food loss and waste by a manufacturing execution system integrated with the IoT platform that are connected to the shop floor sensors. INESC TEC, the role of the INESC TEC in this iFishCan consortium is, the consortium is led by ASTI and includes iTalento and also the Food in Tech. The role of the INESC TEC is developing data gathering system able to feed the high-level systems with data from the shop floor. For this demonstration, we started by analyzing the production process and identifying the production stages with impact in the food loss and waste. In the bottom of this slide, we can see the main production stages, and from the left to the right, we have the fresh fish reception, the brine, the fish preparation and washing, the cooking process, the canning, the sterilization, and finally the packing. So we started by analyzing the production process, and then we selected the sensors and implemented the scripts to get data from the industrial equipments. And in parallel, we developed the IoT platform that connects the sensors with the high-level systems. The IoT platform also stores the shop floor events and provides a dashboard that shows in almost real time the production parameters. So for this demonstration, we have two types of sensors, a flow meter and the energy sensor. The flow meter will be installed in the, in the preparation stage here, where a large amount of water is used to clean the fish before the cooking, and the energy sensor will be installed in the main canning line, and we will also install an industrial scale to measure the weight of the raw materials and subproducts along all the production process. So, the IoT platform as a dashboard where we can see what is happening in the shop floor. We have here the two upper graphs are related to the water flow, and the two bottom graphs are related to the energy consumption. I forget to say that for these demonstration purposes, we created a closed water circuit using a water pump connected to the caudal water flow and the flow meter. Now these sensors are connected to embedded devices that are connected to a dedicated Wi-Fi network. And these embedded devices are running scripts to get the data and publish it on the message broker of the IoT platform. And this IoT platform also provides that information to the other systems that needs that information. This screen here is the presentation layer of the IoT platform and shows, as I said before, data related to the water flow and energy consumption of the water pump. So as we can see, we have around 6 cubic meters per hour of water flow. And if I reduce the water flow, we can see that the energy consumption will also decrease. The two measures are related. Now we have a water flow about 2 cubic meters per hour and a low energy consumption. If I increase again the water flow, the energy consumption will take the normal values. So this type of infrastructure, this data gathering system, is the first step to do when we want to get data from the shop floor and know how to save raw materials and resources like water and energy. And that's all from my side. Thank you everyone for your attention. And if you have some questions, I will. Thank you.
Thank you, Rui. Some questions for Rui? If not, we will pass to the next presentation, the next demonstration, which is going to be a presentation and video. And this is a special one, first because we have our industrial partner of EIT Manufacturing, Sonae, with us, and also because we have the collaboration with a startup. So that's one of the main objectives of EIT Manufacturing, is to bring startups to work with big companies, and that's what this project is doing this year. So I will just ask people to leave this, like the corridor in front of me, just free, but please come forward, don't go backwards, just come forward to see Anna and Rui, who are going to present now. Thank you so much.
Thank you so much, Anna. Thank you everyone for being here, face-to-face and also online. So it's also very good to see some of you for the first time. So actually we've been collaborating with INESC TEC and with EIT Manufacturing for some time now. And some of the teams we hadn't yet met face-to-face, so today was the day, so that's also excellent. So we're going to present one of the, let's say, the intermediate results of a project that we're running this year within the scope of EIT Manufacturing. So it's called Collab for InLog. Thank you so much, Anna. And so we wanted to talk to you a little bit about why we are running this project, and then I'll pass on the floor to Rui to then do the demonstration of what we've been developing. So a first glimpse of, let's say, some of the challenges that we faced within the logistics and the supply chain processes that actually gave rise to the development of this project. So we're seeing, and I think that if you are an industry partner, many of these challenges will be very familiar. So we still see very much a reliance on manual processes. Yes, it's 2021, but that still happens today. Based on exchanging information via email, using Excel sheets or other types of documents to try to coordinate the work that needs to be done. And we also see, let's say, from the side of standardization and let's say local context, some things that when we talk about global supply chain and logistic flows, it does not help. So it brings added complexity that we also wanted to tackle. And something that we also see is a wide range of tools being used, so ICT systems, whose architecture is many times not really tailored for collaboration within the supply chain. So when we say about collaboration within the supply chain, we mean that there are different actors that need to coordinate their actions. Ideally, they would do that also based on the systems that they use. In the real world, that's still quite of a challenge. And which also brings us to the topic of, again, the lack of integrations in an easier way, in a way that it's, let's say, also economically that makes sense, and the never-ending topic of interoperability that it's still a pending matter. So we see a wide range of online platforms trying to solve some of those challenges, but they're still very much based on the manual insertion of information or, again, the use of Excel files to upload information. So we've decided to tackle a part of the problem, a smaller part, I would say, but an important part. And so what we've proposed to do was to develop and pilot a collaborative platform to increase the digital interaction, so the digital transformation of the supply chain processes, both from the perspective of, let's say, the industry stakeholders and also the logistic ones. So we've gathered a team of partners with skills in the area of supply chain, in the area of technology, in the area of industry, to try to come together with a solution. And here, I would say that the key is, so building upon technologies that exist, but bringing them to their next stage of development and piloting them using real industry cases, which is very much, let's say, the scope of innovation that EIT Manufacturing is looking for. So we've been running this since January this year. So it's a one-year project, so we're now coming to the final stretch. And we've decided, because we couldn't tackle all logistic processes, so we've looked for a use case for our colleagues at Sonae Arauco, so manufacturers of wood-based panels sold around the world in over 70 countries. And an important portion of that, of that outbound logistics is done by maritime transportation. And this is done through to regular destinations and also to what's called spot destinations, so depending a little bit on how the market is. So this also brings some additional complexity, because there are, let's say, markets which are very common, to which the colleagues are very known to dispatching goods, and others that they, from time to time, need to make sure that they put them out there. And why we also chose this? Because it's particularly challenging since it involves a diverse range of participants. So it's still a very interesting process in a way that it has many stakeholders doing a small but very important part of the process. And it entails particular challenges and needs also, given, let's say, the digital sophistication of some of those stakeholders, or better saying, the lack of it. So it could be, it could benefit a lot, let's say, from collaboration and from an easier exchange of information within the process. So we've mapped here a very highly simplified version of the process. So we have, from a manufacturing site or a central warehouse, we then typically have the transportation to a port where consolidation is done. Then we have the transportation itself, the maritime, and then we have a number of processes also at the destination port. Why? So while we were developing the project, I would say that its importance also grew, because we're seeing that with, let's say, the revival of economic transactions, with the revival of the logistic flows, we're seeing heavy bottlenecks in what comes to receiving and dispatching raw materials and receiving and dispatching finished goods. So for example, also related to our use case, this is a very recent news from the Wall Street Journal saying that shipping goods at this stage is really very, very hard to do. So which means that if we can get those processes to be more agile, with less errors, making everyone's task easier, it will really be very beneficial because it's really a critical topic at this stage. So to show a little bit what we've developed and the work in progress that we have, I'll pass on the floor to Rui.
Hello, everyone. Good afternoon. Well, we heard Javier saying that 99% of the companies in Europe are SMEs. So, being an SME have a lot of advantages, but it creates a lot of constraints and restrictions. By saying this, in this world of manufacturing, we have both. In fact, when we think in manufacturing, we think also on logistics. And every time we talk about logistics, we think, okay, internal logistics, yes, really important, but we need to have the other face, the logistics to have raw materials in our production fabrics and our products at the final client or the warehouses for distribution. So, what we heard in the past decades was the development inside the manufacturing and inside the logistic companies. It was a reality. Everyone developed their own systems. But nowadays, in this century, in this year, 2021st, we have a big gap between these two worlds. Logistics work by themselves, manufacturing work by themselves. And sometimes they exchange information by exchanging files, text files, emails, etc. This is not something that we want to have in the next coming years. So, by saying this, I want to show you one part of the results that we produced. The platform that we developed to interconnect all these entities. And I would say the focus is really the SMEs, because they need to get our help to develop themselves, to help them interconnecting their systems in a very smooth way with the systems of large companies and the other players. So, I'm going to play a video where you will see the process of interacting for those who have already their own systems and who doesn't. In this case, they need to get quotations from several entities, and most of the times they have to request them by email. So we changed this for a very simple way of requesting information. A search engine where everyone can ask for a service, a transport service from one place to another, and by choosing the kind of service. Then the platform does the magic, goes through catalogs of services from logistic companies and gets the results. Different results from different companies, being able to compare conditions, prices, duration, CO2 emissions. That is something that is brand new in this market, and get all the information about those services. By having these, the companies, the manufacturing, do not have to exchange several emails asking for the conditions, then produce Excel files to compare the conditions, etc. They have all the information in just one place by filling 3 fields and clicking on search. After this, they can request a quotation for the service. This quotation can be sent for 1, 2, 3, 50 companies in logistics, and they will be advised to answer to this request. After this, once again, the request for quotation is a very basic information about what they need to transport and the kind of conditions, specific conditions. Later, we could add much more information about the materials, the products, the freezing conditions, etc. At this stage, it's not useful to have all this kind of information. What we have here is the really important aspects of the request. The prices they want to have, because we saw prices here, but the client can ask to have special conditions in some cases. As Anna said, there are two ways of interacting between the manufacturing and logistics. One way is by having contracts for a period of time, 6 months, 1 year, and the other one is to have spot, to take advantage of the spot services and request for a specific service at a certain time. So, by having these, companies are able to request these kind of quotations for both, for services that are repeated and services that are just one time requested. Right now what we have is the answer from these two companies, in this case are virtual information of course for the presentation, but by having these, people can compare the proposal from each one of the companies and produce something that in the case of Sonae took some weeks to be prepared. Here it was just one click because the information was filled already, so they didn't have to fill again another Excel file, submit the file, exchange the file between the collaborators, etc. Everyone in just one place. Then they can accept or not. They can pick the best proposal, not only the best price sometimes, but the best proposal and accept. The provider will be asked to execute the service. So, from now on, the platform will support all the process that needs to be filled, all the formalities, all the documents, all the data can be inserted in the platform. I am showing the platform. Why? Because I cannot show you the exchange of information between systems. Well, in fact, I could have here some black screens sending messages from one system to another, but it's not so funny as this one. But right now, what we have is the planning, and the platform is showing the planning phase. Everyone can insert here what will happen in the platform and between the logistic parties and the manufacturing and all the other parties, the customs clearance, all the weighting of containers, etc., the stuffing partners, etc. Everyone is able to upload documents, to fulfill some of the official documents like the VGM, like the bill of lading, the CMR, all of this for you maybe doesn't mean much, but all of these are documents, official documents that must follow the cargo. So it's, I would say, easier to produce the cargo than fulfill all these official documents and formalities. So in this case, once again, the platform is very interesting, and the exchange of information between systems is something that will help a lot in the daily tasks of the logistics department. Right now, what we have here is the way of filling this document. In this case, this particular case, we are talking about weighing the containers and cargo. It's mandatory. And this information must be sent to the terminal in the port, to the company, the maritime company, and some other entities. Here, today, they have to fill all this information in a specific file and send it one by one. By having this in just one system, everyone will be notified and can download or access directly to their system the information. And finally, a way to see what is happening with all the cargo around the world. So, I would say Sonae have more than one cargo every day and need to know what is going on. Is it red? Is it going well? Is it green? Is there something about formalities, about the progress of the transport? There are some messages being exchanged. Do we need to exchange email? No, we have the chat in the context of each transportation. So once again, everyone can do all of this by following this dashboard and see what is going on with the major deadlines to control everything. Second, the interoperability, Anna told about interoperability, is something that we are working right now, and what we are doing is to apply a technology provided by the European Commission, an open source software that is able to allow interoperability between systems in a very smooth way, not by using the traditional web services that everyone heard about, but no one knows what it is. But well, even me, sometimes I don't know what are they for, but because they are very complex. So by having these kind of technologies, and it is being used by the European Commission in airports, and all of us certainly have had our information going through this kind of software, and we are applying this right now to logistics, to connect manufacturing and logistics systems to systems. Once again, helping small, medium enterprises that do not have resources by using an online platform and mobile apps, and larger companies with complex systems by interconnecting systems directly. That is something that we are producing right now and deploying in these pilots. Well, the partners Anna have already told about, so I want to thank you by seeing our presentation. And the last picture I wanted to share with you, the platform, the set of applications, some of them mobile application, others online, and finally a network, a collaborative network to allow everyone to exchange information without any customization or developments case by case. Thank you. I would say if anyone have questions, Anna is here to answer. Anna are here to answer.
He's already stealing your place, Anna. Be aware.
Thank you.
Thank you so much, Rui and Anna.
Thank you.
No questions for them? Okay, thank you. We will pass to Marcelo again. And this time we have our second demonstration of a cross-kick project. The first one was in the innovation pillar, and this time in the education pillar. So thank you, Marcelo.
Thank you. Thank you all again for being here. Thank you for the virtual presence. I'm Marcelo, and this is Gustavo, and we are going to talk about the VR-based welding simulation. Actually, the virtual reality professional training is a demonstrator implemented under the Redville project, which is an EIT cross-kick. And EIT Manufacturing Consortium is composed by INESC TEC, BIBA, and TU Delft. As you may know, welding is a manufacturing process that joins metal parts using high heat. So welding is a kind of dangerous and unhealthy task, which due to the high temperatures involved, the production of fumes and gases, and also to the risk of explosion and fire. In addition to that, there is a shortage of welders in the market. So an European Commission report ranked welders in the 5th position of the top 28 shortage occupation list. So it's very important for us to address this problem properly. What we are going to demonstrate here is a virtual reality environment. It's an immersive reality that simulates an industrial welding scenario. And in this scenario, the welding instructions will be transferred to the learners that will need to replicate them using the VR headset. The VR system will then track the motion of the learner and of the simulated welding gun and produce a simulated welding part. In addition to that, the system will also simulate sparks, protective gas, electric arcs, and other sort of phenomenon that is currently occurs naturally on this welding tasks. The system will also provide feedback to the user with technical information about the welding process. So information like the welding temperature, the energy transfer, the angle of the welding torch, so the user can improve his performance and perform better in reality. The project pilot targets students from professional schools and also from engineering programs. And participants will be divided into 4 groups, and their performance will be evaluated individually and also compared against each other. So here you can see Gustavo is wearing a VR headset. This headset, as you can see, is different from the other one that we used previously. In this case, Gustavo is not able to see the surrounding, but this gives him an immersion on this simulated scenario. So here we have the headset. We have 2 base stations on the top that will track his movements, and also a computer that is running the simulation. And then the system will tell him the tasks that he's supposed to do, and he will be able to perform the welding in the simulated scenario. We can have several levels of simulation, since simulation for basic trainees until higher level simulation scenarios for people with experience, but that needs recycle or needs to be training for other tasks that they are not used to. Okay? So if you have any questions, I'm happy to address them. Otherwise, we can chat on the end of the session. Thank you very much.
Thank you, Marcelo and Gustavo, for the demonstration. Are there any questions? All right. So I guess we move to the last set of demonstrations we have for you today. Only more 2 to go. And this time, the robots need the space. So this robot is going to move. So I ask everybody to come either here, near me, or to the other side, and again, maintain the corridor free. So this is a project that we will is a Age 2020 project Fasten, that its results have been already applied for EIT Jumpstarter, and they are already in the 2nd round. So this is the way the European Commission sees their program, starting from very ground research to innovation, and then EIT for the exploitation and bring to the market. So without further ado, I'll pass the word to Cesar, who is going to present Fasten. Thank you, Cesar.
Thank you, Anna. Good afternoon. So this will be the demo that will need more space than usual, but we have organized this in 2 different moments. On the first moment, I will show you something on a screen, so that's the screen at my right, and on the second moment we will have the robot moving, and when that starts, the people that are on my left will have to move back in the stage, okay? So that the robot doesn't need to be stopped. So what I'm going to present is something that we have been working on the last 4 or 5 years. So it has been a journey of 2 different groups at INESC TEC. One group that is coming from the robotics research center, and the other group which aims systems engineering in terms of enterprise and manufacturing companies. And about 4 or 5 years ago, we noticed that the collaborative robots that they were starting to develop had one fragile item, and it's related with the fact that most of the time the people working on the robotics have not the required skills to make the integration with manufacturing execution systems that on the shop floor, on the company, are responsible for managing all the work. And so this was our departure point. And what, after several iterations, as always, this is not an easy journey, but after several iterations, we come here on 2 different streams of work. One which is more robotics, advanced robotics, which is not really the topic of this demonstration, even though we will see this moving on, and the other one that I now focus my attention, which is the advanced plant model, the software system that you are showing here on this screen. So this is basically one of the aims of this software, which is a digital representation of the physical items that for the specific purposes of manufacturing are important to manipulate with. So here we have, for example, in the back of this image, we have 3 tables that represent the tables that are here on my left. And you see here some parts in these blue baskets, but we also see in this digital representation, Rui, please zoom out, we see also our robotic manipulator, we see a conveyor, and we see also other objects. So the first aim of this system is to make the information about these objects available to whoever needs it in manufacturing, in the management of the manufacturing. Here we are concentrated on robots. So basically, this we call this the world model. The 3-dimensional model of a given space. This is information that it's aimed to be delivered to the robots so that they have all the information they require to navigate and to do their own tasks. How do we build this model? We start by picking a 2-dimensional image of the floor, which is shown here, and on top of this we make use of a catalog of 3-dimensional objects previously built, and we put those objects on top of the marks that are part of this map. And by doing so, we are picking 3-dimensional models, we are locating them in a given map, and we are in fact building a 3-dimensional model of this space using the same the same coordinate system of the robots that will later on work on this. we saw that my colleague just implanted a new rack in the system that we are now showing, and we can go now to the catalog. So the catalog is the place in the system where we build the three-dimensional models. There are several ways to accomplish this. One of them is, for example, to keep a step model from the web and change their dimensions and import it in the catalog. So that's what we are seeing now. So we can now go to the second phase of this demonstration, and this second phase, it shows the second aim of this tool, which is to get a production plan from a manufacturing execution system, or to build it locally. This is the case in this demonstration. This production plan, in fact, it identifies all the operations the robot will do in a given area. So that's what we can now start. Rui, please activate the production plan. So we have just activated it. What is happening now in the background? Some of the tasks are being assigned to the robots. In this demonstration, we only have one robot, and as soon as the robot gets this task, it starts to implement it. In this case, it was a first task that instructs the robot to navigate in the field. This robot will target one of the basket, the blue basket that is on a table at my left, which represents an area in a logistics warehouse where pieces are available and that can be used to build kits that afterwards can be transferred automatically to an assembly line where they will be used to produce or to assemble some products. So now the robot is implementing several things. First of all, it is recognizing the object that is there. He was instructed to pick a particular piece from this advanced plant model, and when it recognizes an object, it uses some of the information that is in this software to make sure that the object that was picked is the right one. So this is a second piece that the robot is now picking. He's putting in a box that is being carried by the robot, and it will continue its work. I am highlighting in this moment some of the information that is being used. So this is the three-dimensional visualization of one of the parts that is being processed by the arm, and these green and red arrows, these are the different poses, the different places in the pieces in the piece that may be used to grasp a given that given part. And this is another example of information that is not in the robot when it started to work. It's in this information system that is propagating this information to the robot in terms of the context, in terms of the needs for realizing that task. And now the robot has finished that production plan, that mission. It will just park on its final position. As you are seeing, we don't have too much space in this laboratory for this kind of demonstrations, but what this demonstrates, and we have done this in the past, is that in a logistic warehouse, we can use the robot afterwards to transfer these kitting boxes to a given place in an assembly line. And just to finish our presentation, I thank my colleagues that are in the back end controlling all of this. Just to mention that as this was a result from these two groups in the last 4 years, we have now entered in a new phase this year, and we have engaged into the IET Jumpstarter initiative in order to start exploiting this result in terms of business. So our aim, if everything goes right, is to have a startup exploiting this technology from point of view of the software, but also all the software that is running inside the robot that we can see, but that it is there for sure. Thank you.
Thank you so much, Cesar and Rui, for the demonstration. So we can now, if there are questions? No, so we can now to the last demonstration of today with Germano. And this time, Germano will tell us the story on how all this technology goes from here to our industry. So thank you, Germano.
Hello. Good afternoon. Thank you, Anna. Thank you all. I will try to show you a little bit of the end of the cycle. In this case, we are using a European project called Scalable. I will very briefly present you the project and then how we transfer it to the market, actually to industry. The European project Scalable it ran until 2020. There were several partners from Portugal, one end user, Simões Plásticos. Then we have another end user in France, PSA, and then we have Fraunhofer, Aalborg University, and Lund University. The name Scalable comes from scalable automation systems, and the idea was to define the right level of automation for different scenarios. Basically, we had two different realities on the Portuguese use case at Simões and at PSA. At PSA, we are talking about the engine assembly line. These assembly lines are highly automated, and their problem is basically the excess of automation. Basically, the investment that they need to make in robots and automation systems, it's too high, and they do not know how is going to be the production of a certain engine type, and they want to lower the initial investment to allow to adjust the investment to the life cycle of the product. On the other hand, on the Simões use case, we had an under-automation problem. They were relying on human workers to perform certain tasks that could be automated with the right tools. And basically, we combine both use cases in this project. This is the PSA use case. You have the engine in this table. It's basically performing some assembly tasks on this engine, and this was part of the challenge. If you want more details on this use case, I can give you later, but I would like to concentrate more on the Simões use case. In this case, if you know the plastic injection sector, basically you have the injection machine that is the main pacemaker of the plant, and then most of the time you have small lines for packing or for assembly right after the injection machine. And this creates these small islands of automation around a certain machine. The idea here was to change this concept, to have several injection machines providing parts to a single conveyor, and then make the subsequent tasks in a proper place, in the end of the line. And the idea is for this space to be more flexible in terms of the robots and the operators that are located in this task. We made The conveyor that you see on the right of the lab was the demo conveyor where we made part of the developments here at INESC TEC, and the video that we are going to show you shows the performance here before we went to the plant. Before we move, I would just briefly want to show you some of the parts or the building blocks that are behind this project, software-wise. One of them is the advanced plant model. That's the green circle that you see on the top, and Cesar just presented it. And it's basically our aggregation, digital twin, call it whatever you want, but it's basically our central point for data on the manufacturing side. Then we have three main blocks, one on flexible robotics. To achieve this scalable automation systems, we need robots that are more flexible. Then we had simulation and decision support to support the manufacturers, plant managers to decide on how they are going to apply these flexible robotic systems. And finally, a more advanced manufacturing execution system. In this case, for the central pillar, we had the chance to go with Critical Manufacturing, a Portuguese MES manufacturer, and they were the main developers of this component. On the simulation decision support, today was not that long, but some of our colleagues here at INESC have developed this part, and also on the flexible robotics. This video is the video that I will need help, I think. I will need help to play the video. Okay, this is the line that you see here on the lab, and as you can see, we are just placing a robot on the assembly line. These are blisters that are used to transport the products inside the production line. This is part of our software to program the robot. Here is the interface for the advanced plant model that Cesar just showed before, where it is defining the layout of the system, where the conveyor is and where the robot is placed. Here is the 3D representation of this system. Then we have another interface. All of these interfaces just go to the APM. In this case, is to define the grasping position. As Cesar shown before, we have algorithms for automatically generate grasping positions, but in this case, we were using operator interface to do it. But all these pieces of software benefit from the single entity that rules all this data. This is the MES that is generating the working order. And I would like to get the point. Okay, now the robot is running, basically placing the blisters for certain parts. This white robot is not part of the show, it's just making the injection machine roll here. It's placing the parts without a specific position. We have 3D vision on the robot to pick both parts. And in this case, we had two robots picking parts on both sides of the cell. Okay, here you see the execution of the robot program in this case running behind the scenes. And as soon as the robot finishes one blister, it places the blister on the box. When the robot does this, placing the blister on the box, in the production line, some parts just go. The idea here is not to have a completely automated system. We are combining one operator and two robots to manage 4 injection machines. It's more than enough. And the robot and the operator can do several tasks, and one of them is to pick up the leftovers and correct this. Okay, this is an important step. Basically, what we have done here was to stop the process, freeze all the data, and this data is given to the simulation engine developed by our colleagues at the at sales center. And basically well, it was too fast, or I was talking too slow, but basically they were adjusting the parameters for, okay, if I put one robot, what would be the throughput, if I put 2 robots, and so on. Basically, having this data concentrated on the advancement model allow us to have, well, historical data and data to support scenario development. And now for the real transfer. Need help again. This video is from the plant. It's not the final version of the robot. Actually, here we only had one robot. Right now we have 2 of them in production. But you will see the complete layout working. Basically, here we have 2 conveyors. We need space for the parts from all the machines. This is the real injection machine. Here is a specific operation on cutting specific component on each of the parts. And then is similar what you have saw. Machine vision to allow the robot to pick parts in any configuration. Using this type of flexible robotic systems allow us to pick the parts in whichever position, but also, for example, in the end of the day, you pick up the robot, you bring it to a warehouse, you bring it back on the day after, and everything runs smoothly. It was quite an impact on Simões' maintenance team when they realized that they could move the robots and they will still work in the day after. Okay, this is the sensor. And then I think we were going to check on the safety. These robots are collaborative robots, but in fact, to keep up with the speed of the line, it's not that fast, but collaborative robots working without fences, they are slow. We combine the collaborative robot with a couple of lasers on the platform to allow, if there is no one around, for the robot to just speed up. I think in the previous demo, when the operator comes, the robot just slows to the collaborative speed. And well, this is the replenishment of the blisters. Right now, the robots are quite different. They have piles of blisters on both sides. You know, industrialization step. Basically, this was the 3rd test sprint. The last one was on June, and the robots are fully running from the beginning of this year. Well, June 2020, and they are fully running from the beginning of this year. And now Simões is replicating this multi-product line in several places of their plants or their plants. Thank you.
Thank you so much, Romano, for explaining us his experience. And so it is my task now to close the session. And I would like to close it with an invitation. So I would like to invite you all to our last event of the year, which is going to happen at IMAF on the 3rd of December in the morning, where we'll do a workshop and also a matchmaking activity for preparing consortia for the calls of next year. So I invite everybody who is online, everybody in the room to join us. I will certainly give you the details later. So, and now it's time to thank everybody. So, special Teresa and Javier that came all the way from San Sebastian to Porto. Thank you for coming. To Wen from Sonae and Rui from MITMYNID to be here as our guests, and to all the 15 people at INESC TEC that worked hard for all the demonstrations and all the presentations to work. And also, please give me a hand for future data, for Tanya, Bruno, Nuno and Gilles for making this possible here and online. Thank you. So, and with that, we close the session online. You will have nice videos to see. And for the people in the room, I invite you to go to the training room again and have some snacks. And see you all on the 3rd of December. Thank you. Enjoy. Thank you.
The manufacturing sector has evolved over the decades, constantly adapting to fulfill the needs of economy and society. In its Industry and Innovation Lab, the iiLab INESC TEC aims to disclose the state-of-the-art in advanced production technologies, thus contributing to the industry's smart, sustainable and technology-based growth. Created in 2019 and headquartered in Porto, Portugal, the iiLab is a space for demonstration of research, experimentation, validation of new concepts and advanced training. The lab supports technology-based innovation in public and private organizations, thus enhancing their skills in the development, adoption and implementation of advanced production technologies. iiLab showcases a wide range of technologies such as mobile robotics, industrial vision systems, simulation, business intelligence and decision support systems, cyber-physical systems and Internet of Things. The lab provides a controlled, near-industrial test environment with production simulators, collaborative manipulators, cargo transport robots and IoT platforms. The technological demonstrators installed in the iiLab are transferred to different industrial sectors such as automotive, aeronautics, machinery, metalworking, textile, footwear and logistics. iiLab also provides professional training in digital transformation management and advanced production technologies for senior managers and engineers of manufacturing companies and technology providers. A specialized and experienced multidisciplinary team provides counseling to companies in order to support their digital transition and development of new and customized solutions. The laboratory works in close collaboration with other national and international initiatives, such as National European Digital Innovation Hubs and EIT Manufacturing, in order to spread digitization technologies across all industrial sectors in the region, thus accelerating the development of new industrial technologies and maximizing its impact, promoting the digital transformation and competitiveness of manufacturing companies.
How we make things in the world is changing. Some people are worried. We're not. We see it as an opportunity to become fully digital, climate neutral, and highly innovative in these challenging times. And EIT Manufacturing is leading the way. We're creating a Europe-wide community of businesses, students, researchers, engineers, workers, digital nomads who are all working to improve your everyday life.
Hello, my name is Aurea Rodriguez.
My name is Harry.
Nuno Gouveia.
Sebastian.
From France.
From Portugal.
We want to help
reduce energy waste
to transform and accelerate the European industry into the digital era. Bye.
Bye, guys. See ya. From a network of industry heavyweights to up-and-coming startups, we're constantly on the lookout for great partnerships. By pairing knowledge, talent, and the right skills, we're able to challenge what we already know and create the unexpected.
We want your ideas to come to life quicker, your investments to reach markets smoother, and to create more resilient supply chains. It's worth fighting for. New friends, new skills, and smart machines fully connected using fewer resources and taking care of the planet. We're not just about education and innovation for the industry, but we're also about ideas that drive society forward and make it grow. A new Europe is emerging. It's green, connected, and digital. Are you ready? We are. Be part of the change.
The manufacturing sector has evolved over the decades, constantly adapting to fulfill the needs of economy and society. In its Industry and Innovation Lab, the iiLab INESC TEC aims to disclose the state-of-the-art in advanced production technologies, thus contributing to the industry's smart, sustainable and technology-based growth. Created in 2019 and headquartered in Porto, Portugal, the iiLab is a space for demonstration of research, experimentation, validation of new concepts and advanced training. The lab supports technology-based innovation in public and private organizations, thus enhancing their skills in the development, adoption and implementation of advanced production technologies. iiLab showcases a wide range of technologies such as mobile robotics, industrial vision systems, simulation, business intelligence and decision support systems, cyber-physical systems and Internet of Things. The lab provides a controlled, near-industrial test environment with production simulators, collaborative manipulators, cargo transport robots and IoT platforms. The technological demonstrators installed in the iiLab are transferred to different industrial sectors such as automotive, aeronautics, machinery, metalworking, textile, footwear and logistics. iiLab also provides professional training in digital transformation management and advanced production technologies for senior managers and engineers of manufacturing companies and technology providers. A specialized and experienced multidisciplinary team provides counseling to companies in order to support their digital transition and development of new and customized solutions. The laboratory works in close collaboration with other national and international initiatives, such as National European Digital Innovation Hubs and EIT Manufacturing, in order to spread digitization technologies across all industrial sectors in the region, thus accelerating the development of new industrial technologies and maximizing its impact, promoting the digital transformation and competitiveness of manufacturing companies.